Okay, so I'm just going to record this question because this is the one that's going to be on your quiz and I want to get it up as fast as possible. So the first thing you want to do when you get your quiz is you're going to want to write the cast rule up in the top corner just as a quick reference. So when you see this question, given point P on the terminal arm of theta 1, the first thing you're going to want to do is sketch it. On the quiz, I'm likely going to even sketch the first step here. So our x value is positive and our y value is negative. That means we're going to be here in quadrant 4. So we'll draw our initial arm and now connect it to our terminal arm. And this is going to represent our unknown angle, theta 1. The first question here is asking us to determine the primary trig ratios for theta 1. So in order to solve that, we're going to have to find the missing side. Remember our triangles now, the right angle triangles. We label them as x, y, and r. So we have our x value here of 3. We have the y value of -11. So what we're missing here is our radius. So to find it, we can just use the Pythagorean theorem. Plugging in 3 squared plus -11 squared is equal to r squared. So on the quiz, you only need to write this step here, and then you can jump to the final value. I'll write up here rounding to the nearest decimal point. So here this can be 11.4. So this value here is 11.4, and now that we have that, we can write our trig ratios. So recall sine theta 1 is going to be equal to y over r. So in this case, it's -11 over 11.4. Then we have cos of theta 1, which is equal to 3 over 11.4. Then we have tan of theta 1, which is going to be y over x. So that's going to be -11 over 3. So that's step 1. Now we need to determine another angle of theta 1, determine another angle theta 2 that has the same sine ratio as theta 1. It's important that we notice it says sine ratio. So we're checking this ratio here, and notice our sine ratio is negative here. We can always double check here with our cast rule. So our angle is in quadrant 4. Quadrant 4 is labeled C for cosine, which means only the cosine value, the cosine ratio, should be positive. That's reflected here, where only our cos is positive and our tan and sine are negative. So we're looking for the same sine ratio as theta 1, and because we identified it as negative, we need to look for another quadrant where sine is negative. Looking at our cast rule up here, we see that sine is positive in quadrant 2 and quadrant 1, which means it's going to be negative in quadrant 4, which we already have, and quadrant 3. So I'll include another step here on the quiz that says sketch theta 2. So doing that here, we'll draw a terminal arm in quadrant 3. And now we've found another angle known as theta 2, which has the same sine ratio as theta 1. So the second part of the question is to find the values of theta 1 and 2. These two angles have the same trig ratio, which means they share the same beta angle, reference angle. So in order to find their values, an easy way to do that is to find beta, the reference angle. So we can use any of these trig ratios here. They should all give you the same value. Just because it's first, I'm going to do sine of beta is equal to minus 11 over 11.4. Remember though, even though this says minus 11, 11.4, the reference angles are always positive. So I punch that into my calculator, pressing the sine to the power of minus 1 button. Then I put it in as 11 over 11.4. Rounding to the nearest degree, I'll write that on the test, is going to give me beta is equal to 75 degrees. So now that I have my beta, it's going to be really easy to calculate theta 1 and theta 2. So theta 1 is in quadrant 4, which means it's going to be equal to 360 degrees minus our reference angle, which is 75 degrees. So this is going to be equal to 285 degrees. Then our theta 2 is in quadrant 3. So in this case, theta 2 is going to be equal to 180 degrees plus our reference angle, which is going to give us 255 degrees. If you're unsure where we got these formulas from, you can review the 4.2 coterminal sheet, the first sheet we got on 4.2. It'll have the formulas there when we review reference angles. And I also have a video up on that called Chapter 4.2 Part 1. Now that we have the values of our angles, we've checked that off. Now we just need to determine all the primary trig ratios for theta 2. So if you wanted to, you could label the angles here. So that would be minus 3 and minus 11 and find it that way. The same way we found it for theta 1. But because we know they share the same trig ratios, we can just write it as sine theta 2 is equal to 11 over 11.4. Notice I'm leaving a space here because I don't know which ones are negative or positive yet. Cos theta of 2 is equal to 3 over 11.4. And tan of theta 2 is going to be equal to 11 over 3. Now, using the cast rule, I'll write it here so I don't have to scroll up. Theta 2 is in quadrant 3, where only tan is positive. So that means I put my negative values in front of sine and cos and leave tan as positive. Double checking over here on our graph, I see that indeed cos would be minus 3 here because we have a minus 3 there. And then as 11 and 3 are both negative, that makes our tan positive. So that was the first question done. And just to review, I'll go over the second question as well. So the first thing we're going to want to do again is sketch the graph. Now in this case, our x value is negative and our y value is positive. So this means our point will be in quadrant 2. Drawing our initial arm as well. We can label the point 8 and minus 5 here for our x and y values. And then our theta 1 will be here. So again, we don't know this side r, so in order to answer the first question, we're going to need to find the missing side, which in this case is r. we'll punch it into the Pythagorean theorem again. So all we need to write on the quiz is minus 5 squared plus 8 squared is equal to r squared. Punching that into our calculators gives us 25 plus 64 is equal to r squared. Punching that into 25 plus 64 is equal to 89. The root of 89 is, rounding to 1 decimal, 9.4 equals r. You only need to write these two steps. So now that we know this is 9.4, we can find the trig ratios. So sine theta 1 is going to be equal to y over r, which is 8 over 9.4. Then cos of theta 1 is going to be equal to minus 5 over 9.4. Tan of theta 1 will equal to 8 over minus 5. When writing it on your quiz, try to keep it neat, not like I did right here. Like that. And so again, let's just double check with our cast rule if we're in the right quadrant. So we're in quadrant 2. Quadrant 2 is the sine quadrant, so only our sine trig ratio should be positive. And we do indeed see that represented here, where our cos and tan are negative, but our sine is positive. So now that we have the trig ratios done, we can determine another angle that shares the same sine ratio as theta 1. So our sine of theta 1 is positive here, and the only other quadrant it will be positive in is quadrant 1. So we'll draw another terminal arm here in quadrant 1. And we'll denote this missing angle as theta 2. So that's good. Now we're going to state the values of theta 1 and theta 2. So they share the same trig ratio, so we'll share the same reference angle. So our next step here will be to find beta, the reference angle. Again, you can use any of these three trig ratios. I'm just going to use sine because it's the first one I see. So that's going to be 8 over 9.4, where beta is equal to rounding to the nearest degree, 58 degrees. So now we have all the tools we need to calculate theta 1 and theta 2. So theta 1 is in quadrant 2, where theta will equal to 180 degrees minus the reference angle of 58 degrees. So that's going to give us 122 degrees. Then theta 2 is in quadrant 1, where we know that theta is equal to the reference angle, so this will be 58 degrees. So now that we have the values of theta 1 and theta 2, we can determine all the trig ratios for theta 2. So in this case, once again, I'll just copy the values over here. Sine of theta 2 is going to be equal to 8 over 9.4, leaving space in case it's negative. Cos of theta 2 is equal to 5 over 9.4. Tan of theta 2, I'll give you guys more space on the test, or the quiz I mean, is equal to 8 over 5. So I've left the spaces negative. We're in quadrant 1, where all of the values are positive. So I'll just leave this empty with no negatives. And now we are done. So if you have any more questions, you can practice these two on your own at home, or make up your own points if you want more practice. If you have any questions, you can find my email on the Brightspace, christopher.owen@tdsp.owen.ca. Good luck, guys.